Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of error handling, retries, and triggers in Salesforce, covering best practices and providing detailed code examples. Understanding the landscape, errors, triggers, and asynchronous processes. Before we get into the code, it's crucial to understand the environment where triggers operate and the challenges they present when dealing with errors. Triggers are Apex code that automatically executes before or after specific database events, insert, update, delete, undelete, occur on Salesforce records. They are a powerful way to automate business logic, but they also need robust error handling because failures in a trigger can disrupt the entire transaction. Transaction context. Triggers operate within a transaction. This means that if an exception occurs within a trigger and is not handled appropriately, the entire transaction will roll back. This means that none of the data changes will be committed to the database. While this ensures data integrity, it's also undesirable if you only wanted part of the transaction to fail. Governor limits. Apex code in Salesforce is subject to governor limits. These limits restrict the amount of CPU time, SOQL queries, DML statements, and other resources that Apex code can consume. Retrying operations increases the risk of hitting these limits, so it's important to implement retry strategies carefully. DML in triggers. Performing DML, data manipulation language, insert, update, delete, operations inside a trigger can lead to recursion, the trigger calling itself. This can quickly lead to governor limit exceptions and can create infinite loops that will break your application. Bulkifying DML and using appropriate error handling is crucial. Synchronous versus asynchronous. Triggers generally run synchronously. This means they execute immediately as part of the user's request. Asynchronous processes, like queuable Apex, future methods, batch Apex, and scheduled Apex, run at a later time. Asynchronous processes are better suited for longer running operations that may exceed governor limits in a synchronous context, or operations that don't need immediate results. You will often use asynchronous Apex to handle retries. The problem: why retries are necessary in triggers. Errors in triggers can be caused by several factors. Data validation rules. Validation rules prevent records from being saved if they don't meet certain criteria. Unique constraints. Fields with unique constraints will throw errors if you try to insert or update records with duplicate values. Integration issues. When integrating with external systems via callouts, HTTP requests, temporary network issues or service unavailability can cause failures. Concurrency issues. Multiple users or processes trying to update the same data at the same time can lead to locking errors. Governor limit exceeded. You might hit governor limits, such as the number of SOQL queries or CPU time, especially in complex triggers or batch updates. Instead of simply letting these errors cause a complete transaction rollback, a well-designed retry mechanism can improve the resilience of your triggers by automatically attempting to recover from transient errors. Retry strategies: how to implement retries in triggers. Here's a breakdown of different retry strategies you can employ. 1. Immediate retry, use with extreme caution. The simplest approach is to immediately retry the failed operation within the same trigger execution. This is generally discouraged because it can lead to infinite loops, quickly consume governor limits, and make debugging very difficult. When to consider only for very specific, short-lived, and extremely rare transient errors and if you have absolute certainty that the retry will succeed almost immediately. Example: a very short delay in a calculation based on a value on another object. Asterisk code example, illustrative, not recommended for production. Important asterisk this example is primarily for demonstration purposes. In most real-world scenarios, immediate retries are not a good practice within a trigger. 2 asynchronous retries, recommended. Asterisk the best approach is to use asynchronous apex to handle retries. This allows you to move the retry logic out of the trigger's synchronous transaction, preventing it from blocking the user's request and reducing the risk of governor limit issues. Asterisk techniques asterisk. Asterisk queuable apex asterisk queuable apex allows you to chain jobs together, making it ideal for retrying operations. Asterisk future methods run asynchronously, but they don't provide as much control over chaining and monitoring as queuable apex. Asterisk batch apex asterisk useful for processing large sets of data where failures are more likely to occur. Asterisk queuable apex example, highly recommended. Explanation asterisk. Asterisk account update retry class asterisk this class implements the queuable interface. It takes a set of account IDs and a retry count as input. The execute method attempts to update the accounts. If an error occurs, DML or other, it queues up the job again with an incremented retry count. Asterisk account trigger asterisk the trigger iterates through the account records in trigger.new. If an error occurs, simulated in the example, it adds the account ID to a set of failed accounteds and adds an error message to the account. Finally, it queues up the account update retry job with the failed accounteds. Asterisk retry count asterisk the retry count is used to prevent infinite retries. After a certain number of attempts, example 3, the job stops retrying and logs a failure. Asterisk error handling asterisk the account update retry class includes try-catch blocks to handle potential exceptions. If an exception occurs, it logs the error message and requeues the job. Asterisk ACC adder asterisk this method adds an error message to the account record, which will be displayed to the user when the transaction rolls back. Asterisk testing asterisk to test this, create a new account, then update the account. The trigger throws an error. Since it throws an error, it will trigger the account update retry job. Asterisk important considerations if you use this pattern and use ACC adder on the record, then the whole trigger context will fail. This means anything else you're attempting to do in the trigger will also fail. So, only use ACC adder if you want to fail the whole context. 3. Using a custom error log object asterisk. Asterisk create a custom object to store error information and retry attempts. This is useful for tracking and managing errors across multiple triggers and processes. Asterisk example asterisk. Explanation asterisk. Asterisk error log __ C asterisk a custom object with fields to store the object name, record ID, error message, retry count, last retry attempt, and a flag to indicate if the error has been resolved. Asterisk account update retry with log asterisk similar to the previous example, but it also updates the error log __ C object with the retry count and last retry attempt. Asterisk trigger asterisk creates an error log __ C object when an error occurs and queues up the account update retry with log job with the error log __ C ID. Asterisk benefits asterisk. Asterisk provides a centralized place to track and manage errors. Asterisk allows you to analyze error patterns and identify areas for improvement. Asterisk helps you to prioritize error resolution. Best practices for error handling and retries in triggers. Asterisk bulkify your code asterisk always process multiple records at once in your triggers to minimize the number of SOQL queries and DML operations. Use collections, lists, sets, maps, to handle multiple records efficiently. Handle exceptions carefully. Use try-catch blocks to gracefully handle exceptions. Log the error message, stack trace, and relevant record information to help with debugging. Avoid immediate retries. As mentioned earlier, immediate retries are generally discouraged. Use asynchronous retries instead. Limit retry attempts. Implement a retry count to prevent infinite loops. After a certain number of attempts, stop retrying, and log the failure. Use exponential backoff. Instead of retrying immediately, wait a few seconds, then a few more, and so on. This can help to avoid overwhelming external systems. Design for idempotency. Make your retryable operations idempotent. This means that if the operation is executed multiple times with the same input, it should have the same result as if it were executed only once. This is important to prevent unintended side effects if a retry is executed after the original operation partially succeeded. Monitor and log errors. Implement a robust error logging mechanism to track and analyze errors. Use custom objects, platform events, or external logging services to capture error information. Monitor your logs regularly to identify and address recurring issues. Test thoroughly. Write unit tests to ensure that your error handling and retry logic works as expected. Test different error scenarios to verify that your code handles them correctly. Consider platform events. Platform events can be used to decouple the error handling and retry logic from the trigger. The trigger can publish a platform event when an error occurs, and a separate process, example a platform event subscriber, can handle the retry logic. Use asynchronous apex for long-running operations. If your trigger involves complex or long-running operations, use asynchronous apex to avoid hitting governor limits and improve the user experience. Example, exponential backoff with queuable apex. Key improvements and explanations. Exponential backoff. The delay seconds variable calculates an increasing delay based on the retry count. The delay grows exponentially. System.schedule. The system.schedule method is used to schedule the job for execution at a later time. This is the core of the exponential backoff strategy. The cron expression creates a one-time schedule for the time you want to execute the job. Delayed queuable class. The delayed queuable class implements the schedulable interface and simply enqueues the original queuable job when it is executed. Cron expression. The cron expression is used to specify the date and time when the job should be executed. For a one-time scheduled job, you can set the cron expression to the current date and time plus the desired delay. Important considerations. Scheduling too many jobs can lead to governor limit issues. The minimum delay for system.schedule is 1 minute. Make sure the schedule job name is unique. Be aware of the impact on the schedule job's limit. In summary, error handling and retries are crucial for building robust and resilient triggers in Salesforce. By using asynchronous apex, queuable apex, custom error logging, and exponential backoff strategies, you can create triggers that can gracefully recover from errors and ensure that your data is processed correctly. Remember to test your code thoroughly and monitor your logs regularly to identify and address recurring issues. Always be mindful of governor limits and design your code to be as efficient as possible.